Welcome to Pomodoro Joe for Tuesday, February 21st, 2023. Today we're doing LeetCode problem 540, single element in a sorted array. This is a medium problem. You are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return the single element that appears only once. Your solution must run in O log of n time and O of 1 space. All right, so with that, we'll put 25 minutes on the Pomodoro timer and get started. I'll start with the result. Since it's an int, I'll set it to 0 to start. And we will return the result at the end. So I know this is fundamentally a searching problem. I'm looking for a single element in a sea of pairs of elements. And I know my search space is the entire length of nums when we start. But I also know that I have to reduce that search space by 50% every step in my process. That's what they mean by O log of n runtime. All right, so I need to have some way to define the space that I'm searching. We'll start with a low and a high index. Okay, so now my low and my high index will define the current search area. This will change over time. I'll be either moving low up or high down, cutting out half of my nums every step in the process until high and low converge. So in order to define my two different halves, the low half and the high half, I'll need to have one more index, the midpoint. And we'll set that to 0. And now we'll start our process. So while the low index is less than the high index, we will be moving the low high or the high low until the two converge. Now I need to find the midpoint. So what's the midpoint between low and high? Well, we'll have high minus low. That will give us how many elements are in between high and low. Then we'll divide that by 2, an integer divide by 2. So this will tell us half of the elements between high and low. Now I need to not just get half the elements, I need to start it from someplace. So it's going to start at the lower index, add half the elements, and that will give me the halfway point between high and low. The next thing I need to do is figure out which half to eliminate. We need to figure out which half contains our target solo integer. Now, how do we do that? That's going to be the tricky part. Well, one thing we can note here is because our initial array is sorted and all of these numbers are pairs except for the one solo number, all the paired numbers will be grouped together. That's what the sort gives us. And because they're all grouped together, we can say grab any index, and it means that the matching pair will either be the next one up or the next one down. One other thing we can notice, in the beginning, we're starting at index 0. That means 0 and 1 are a matching pair. 2 and 3 are a matching pair. 4 and 5 are a matching pair. All of these matching pairs are going to start on an even index and have the matching paired number on the next odd index. So 0, 1, 2, 3, 4, 5. So that gives us a clue as to maybe how we'll solve this. Because once we throw in this non-matched pair, it means everything is shifted to the left or shifted lower by 1. We're missing what would have been the matching pair element. And so everything after our solo element is going to start on an odd index for the matching pair. Let's look at example 1 just to verify this. So we have index 0, 1, matching pair. Then we have 2, not matching pair. That's at index 2. Then it's index 3, 4, 5, 6, 7, 8. All of a sudden our matching pairs are starting on an odd index. So I think if we look at our midpoint, find its matched pair, Then we can tell if we are before or after our solo number target. I think the way I'll do this is I'll just say, we found some midpoint. This midpoint may or may not be an even number, so let's just force our midpoint to be an even index. We'll just say if, so mid mod 2 is equal to 1, that means it's an odd index. We'll force it to be an even index by subtracting 1. Now our midpoint is an even index. So in this case, if we are before our solo value, that means that our midpoint plus the next value up should match. So let's see, if our nums at midpoint is equal to the nums at midpoint plus 1, that means we haven't yet gotten to our solo number that will shift everything off by 1. So in this case, our midpoint is before that solo number, so that means our solo number is in the upper half, so we can move our low index up to this midpoint. So that's going to eliminate everything below this midpoint. But we can even do better than this. Because we know that our midpoint and the next element are matching pairs, we can just jump ahead 2 elements. Because we know the mid and mid plus 1 already matched. Let's just jump to mid plus 2. So this is how we handle it if it's not in the lower half. Now what if it is in the lower half? Well, then we'll need to move our upper bound down to our midpoint. So then we say high becomes mid. And eventually we will squeeze our low and high together until they find the right number. And we can return nums at low or high. It doesn't really matter. They should be the same. All right, let's run that, see how we do. And we pass. All right, let's submit it and see if we can get a 90%. Oh, we actually do. I did not expect that. All right, we pass and we beat 97.5% of other algorithms for runtime and 39% for memory. I'm pretty pleased with that. I actually was not expecting us to hit a 90% on the first try. All right, well, I think I will leave it there then. Check this one out. Again, this is LeetCode 540, single element in a sorted array. The code itself is pretty simple. The solution, however, is a bit tricky, especially trying to figure out which half your target value is in. So again, check this one out. See if you can beat my score. All right, that's it for me. Hope you had fun. Hope you enjoyed this. Hope you learned something. Hope you can go out and write better code.